Hello, hi everyone. Thanks for coming to my talk. My name's Alessia. I work at Apollo, and today we're going to be talking about the defer directive. So in the way of a quick overview here, this is what you can expect to hear about today. First, I'll start with a bit of the backstory, giving you some context and history on defer. Then we're going to start with what I'm calling Defer 101. What is it? Why do we need it? When should we use it? And then we're going to move on to some advanced topics, Defer 201, which is going to be talking about how it works under the hood and learning about the multi-part transport protocol that powers it. So starting with a brief history. So the defer and stream directives were first described by Lee Byron at a conference back in 2016, React Europe. And you'll often hear defer and stream spoken about in the same sentence, and that's because they're both the subject of a single RFC, a single proposal to amend the GraphQL specification. We're not going to be talking much about about stream today, so we'll be focusing on defer from here on out. But I wanted to mention stream, of course, and what defer and stream, have in common at a high level is really this, the ability to use a directive to convey to the server that our client wants to receive an initial payload of data and that it's able to accept this streaming response with more data, more items in the case of stream later on. So what stream is used for, it can be used on a list type to get that initial chunk of items and then stream in subsequent items at a later time when they're ready, when the server pushes them up to the client. And so this RFC that encompasses both defer and stream is at the stage 2 draft proposal stage of making its way into the GraphQL spec. And that's really exciting because, well, for one, it's the final stage before full adoption into the spec. And it's also a way of signaling to library authors and maintainers that we can implement support as experimental so that all of you can start using it and providing some feedback and really making sure that the implementation is solid before it lands in the spec. Okay, so let's dig in. Let's talk about defer. What is defer? So defer is a directive that will allow us to deprioritize some fields on a query. And that's a way of signaling to our server that we want to receive an initial payload of data with the rest of the fields. And the fields that we've marked with defer can be delivered at a later time. They're not essential for us to render something to our users. Now, what I think is really interesting about defer is that it encompasses both the directive itself, having this ergonomic mechanism for indicating that we're okay with deprioritizing these fields, but it's the delivery mechanism that I think is really fascinating. It's this protocol called incremental delivery over HTTP, and that is the subject of its own RFC, which is linked here in the slides. And by the way, I'll also take this moment to mention that if you want to view these slides, the link is in the top right-hand corner there, ales.co/defer. So you can click through and read everything that's attached here if you want to dive in a little bit deeper. So back to incremental delivery over HTTP, right? What's really powerful about it is that it's this general mechanism that can power multiple GraphQL features. It's not inherently tied to the notion of directives or defer and stream themselves. And that's what we saw earlier today when Corinne Alpers was talking about federated subscriptions and the multi-part subscription protocol that we're using at Apollo for that client-to-router communication. So it's extremely powerful. Okay, so now we're going to see the problem that defer is going to help us resolve. And by problem, I mean, what kinds of challenges app developers might be facing that would cause us to reach for a defer. But first, I'm going to tell a very harrowing tale of a phishing attempt. What does this have to do with defer? Well, just stick with me for a second. This is the demo app that we're going to be looking at today. I built this app with React and a backend, a Pokemon API that I created and deployed on GraphOS. And I built this demo a few months ago. Didn't really think much of it. I pushed it up to GitHub, deployed it to Vercel, and then a few months went by. I made my slides. I've delivered a much shorter version of this talk at another conference. Just getting the word out about defer. And this week I came back to look at my demo. I opened the deployed version on the public internet, and I saw this really scary warning that there was a deceptive site ahead at deferpokemonapp.vercel.app. And for a second, I thought, oh, maybe my whole identity's been compromised. Maybe someone stole somehow gained access to my GitHub account, which allowed them to put something malicious up here on this Vercel page. But then I remembered that I was building this demo at about 11 p.m. many months ago, and I forgot that I thought it was kind of funny to pretend like my Pokemon app was the About Us page on an agency website or like a About Our Team website. So this was the innocuous text that I put in my demo, which was, our team is a dynamic group of individuals who are passionate about what we do and are dedicated to delivering the best results for our clients. And I even had the thought of updating the title in the document to, your coworkers are Pokemon. And this was enough for Google to mark my demo as a deceptive page that was attempting to trick users into doing something dangerous. I had to add these slides yesterday because I thought, if you all go to open my demo, you're going to think that me joining the Apollo client team and working on defer was all a long con to just pull off this Pokemon-based spear phishing attempt. But actually, as of this morning, the review was successful, people. The process works, so my name has been cleared. You can all go visit deferpokemonapp.vercel.app. Okay, so you're not going to see a warning if you go view my slides and my demo. So we're safe to proceed here. Okay, so back to the demo. This is the demo here, right? Our React app, we're fetching a list of Pokemon, and you see the query on the left-hand side that we're executing every time we click around. So this is my app rendered in an iframe here in these slides. So this is just a live web page, and you can see that we're trying to fetch some details about the Pokemon, some stats, their abilities, their held items, which sounds kind of ominous, but we're fetching lots of data, right? In the case of GraphQL, we have this amazing power to be able to describe all of the data needs of our UI in a single query and fetch it all at once. And in this case, this strength of GraphQL, this advantage it gives us of being able to make fewer network requests, is working against us a little bit, because we know that our single HTTP request is only going to be as fast as the slowest fields here in our query. So in this case, we know that by looking in Studio and examining the telemetry that we have on this request, we come to learn that the Pokemon fields on our query are the slow fields, right? That resolver is assembling some data from different sources. It's unoptimized, right? As a client developer, we're a little bit bummed out by this, right? Our regions could be shown to our users really, really quickly, but we're not able to do that right now, right? In order to do that, we would have to split this into multiple queries, make multiple network requests, but that just feels like an anti-pattern, right? It's not very GraphQL-y. We don't really want to do that. And so that's where defer really shines here. We see that we can wrap those fields that are slower in a fragment, and fragments are the underlying mechanism that we need to use with defer, right? We can't defer individual fields, but we can wrap any number of fields in a fragment that we can defer. And so here, we're using this inline fragment to be able to tell the router that we want every other field as soon as possible, but these fields here can be deprioritized. Stream them in when they're ready at a later point in time. And simply by annotating our query with defer, we see the UX changes immediately. The regions are displayed right away, and our Pokemon stats and abilities take a little longer to arrive. And this is just such a powerful tool in the hands of client developers, right? There's no additional steps that we have to take here. We don't have to notify any of our colleagues on the backend team to do anything additional to support this. With the router and entity-based defer, we get this for free. We get this automatically, and we can use it as needed in any parts of our query. And I think another important thing to note here is that we don't want to just take defer and slap it on all of our queries all over the place, right? There really is, I think, a few considerations around how many additional loading states we're introducing and what the best possible end user experience is here, right? So maybe some fields that are initially below the fold or in a collapsed section of the UI can be safely deferred without causing a ton of jank or layout shift when they eventually load in. Here, I'm using this details element, but maybe this is collapsed initially, like say if you have a comments section or something like that. It's definitely a tool that needs to be used very thoughtfully. And how does this look in our React component? Well, this is what we see here. We have our use query call or use suspense query. And in the case of this example with use query, the important thing to note is that we have this loading Boolean. And once the first chunk arrives, that loading Boolean is going to become false. So we're going to have some data because we have an initial chunk of data. But some of the fields that we would expect on our data property may not exist yet because they might be delivered in a future chunk of data. So in this case, we have to make sure that our Pokemon field exists before we can try to map over the stats. We know that those are fields on the fragment that are arriving at some point in the future. And this works really nicely with use suspense query as well. Your query will unsuspend after the first chunk of data arrives. And now we're going to move on to defer 201, which is understanding what's happening in the browser when we just apply that simple directive to our query, right? That felt pretty magical to me, and I hope to most of you. So I thought it'd be interesting to look at what is the underlying delivery mechanism that makes this possible. So in Apollo Client, when we receive a query that has defer in it, this is the request that we're making under the hood using fetch in the browser, of course. Here, I represented it as a curl request because you can actually, if you're viewing these slides, just click the copy to clipboard button and run this yourself in your terminal. So let's step through this request here. We're making a post request because this is the default. This is GraphQL. We're going to set the content type header to application JSON because we're going to send our variables and query along with our request. Here's where things get interesting. So this is the accept header that the client will specify if your query contains defer. This is going to tell the router that our client speaks this multi-part mixed content type that will be used in the response to be able to convey those multiple messages. And then here, we also see this boundary value, which is the string GraphQL, which we'll come back to. And then we have this defer spec value, which is August 24th, 2022. And this is a value, this is a defer spec specifically, is an implementation detail that the client and router use to ensure backward compatibility and to make sure that, as there are any subsequent changes to the proposal for defer and stream that's in stage 2 before final adoption, that we can handle that on the library level, and developers don't have to worry about that. That will be totally opaque to you, and that's something that the client and router can negotiate and ensure backward compatibility for. Then we have our URL with my GraphOS graph that's deployed there, and our variables and query. And so if you copy this request and run it in your terminal, this is what you'll see. So I'm just going to let it play a couple of times. I'm using this cool tool called Terminalizer to record your terminal. And so what we see is this response type that uses that boundary value of that string GraphQL to demarcate the individual chunks of data of JSON data that are arriving. So sorry if that was too much motion on that last screen. I'm going to just stay on this one for a second so we can look at just the rough shape of the response. And so we see that we have these chunks of JSON separated by this boundary that contains the string that was specified in our request header. And we have the initial chunk with our regions, and then our final chunk with the Pokemon details that indicates this has next false property that tells us that this is the last chunk. And I really am, what I think is so cool about this content type of multi-part mixed is that it was actually created in 1992. It dates all the way back to 1992. And this is an excerpt from the RFC 1341. It was originally, I believe, correct me if I'm wrong, someone in the room would probably know if this is inaccurate, but I think it was created for use with email gateways. And so here it says, the original RFC says, thus a typical multi-part content type header field might look like this. And this is what we just saw in our request that Apollo client made. And we see the content type of multi-part mixed and this boundary value that is about, 20 some odd characters or maybe less of letters and numbers. It's, really kind of just an ugly string, but it needs to be unambiguous, right? Because this boundary is what we're going to use to be able to discern where those chunks of data begin and end. And one thing that I think is kind of a fun fact is that in the case of the way that GraphQL is making use of this content type, the string GraphQL is sufficient for us to be able to determine the edges of our messages, because in GraphQL, we can assume a content type of JSON, and JSON never begins or ends with the unquoted string of GraphQL. Aha! And here we have an example I wanted to give with our Explorer. Hold on, let me jump ahead. Oh, awesome. Yeah, so just diving back in here, this is our, this is Apollo Explorer here. And yeah, I wanted to show this example because as you're beginning to work with defer, you might be running different queries in Explorer, and there's this really cool capability to be able to right-click and extract a selection set into either an inline defer fragment or extract it into its own named fragment. And so there's the inline fragment, and here if we extract it into a defer fragment and then run that query there, we can see the regions arriving right away, and then we have this really cool response timeline at the bottom that allows us to jump back and forth in time as these chunks have arrived. So some really cool tools to be able to start working with defer. And you might be wondering, okay, but how does this look in the browser dev tools if I make a request that's using this multi-part mixed response format and this new content type? Well, old content type, as we saw, that's newly being applied in our GraphQL context here. So the one challenging thing here is that in the browser, we're using the readable stream on the response body to be able to parse those chunks of data and read those bytes. And so we cannot actually preview the response while that HTTP request is still open to the server. So here, this is just a screenshot because it's too difficult to really to demo live. But you can see here, like the little green bar on the right, there's a request that is pending, that's started, right? I clicked on Squirtle, and we're fetching, we've already made the request to the server. And like maybe we've received some messages, maybe we've already received some chunks, but we don't know. We can't see, there's nothing to preview. We only get to see the final message once the connection is closed and we've received all the chunks. This is just how the modern dev tools in browsers work, right? And so here we can see all of the chunks of the messages that have arrived, but it's just a giant blob. This is probably a long string of JSON, and we can't like inspect it or dive into it. So this is a bit challenging in terms of the developer experience here. So this is a somewhat, let's see. Yeah, this is a demo of something I'm working on in the Apollo client DevTools. It's a little bit too big for the screen here, but you can still see the most important part, which is this network tab that we're working on. It's not launched yet, but in the coming weeks, this will be available in the Chrome and Firefox extension stores. Well, I should clarify. The Apollo client DevTools have been available in those extension stores for a long time. It's this feature that will be pushed out in the coming weeks. And so, yeah, the ability to browse individual network requests, especially if you're, like, you may have some requests in your app that are maybe, not caching their data, their network-only requests, or you want to better inspect the errors, the GraphQL errors that you might be seeing. All of these things will be much easier in this network tab. And importantly, you will be able to view the individual messages and chunks and dive into the JSON objects that you receive in real time as they're being received. So this is really useful for defer and also for multi-part subscriptions, again, that uses the same transport protocol and speaks that same multi-part mixed response format. So yeah, would love to get some feedback on this once we ship the first version of the network tab here. And we're almost at the end here. So if you're interested in defer and all of this sounds interesting to you, and you're wondering, can I use these features? The answer is definitely yes. Apollo Client and Apollo Router have supported this for the last year, going back to Summit 2022. And there's a link to a full stack tutorial there if you want to learn more about the router side of the picture as well. And so Apollo Client has supported this since version 3.7. And there are many other servers and clients that support defer. Again, once that proposal entered that stage 2 to indicate that the community should adopt this as experimental, there's been a ton of work that's been done in the community to support this in so many open source libraries, and it's been really, really great to see. And the main thing to keep in mind is compatibility. If you're sort of mixing and matching different libraries to use defer, just check to see which versions of the spec they implement so that there's compatibility there, they can talk to each other. And a final note is that for those who are interested in the use fragment hook in Apollo Client, we're also working on a suspenseful version of that hook in the next minor version, in version 3.9. And I think that will complement this feature set around defer really nicely, because defer uses fragments as that mechanism for encapsulating all of those fields. So thank you so much. There's a link to the slides there. Again, you can view this deck at aless.co/defer. And I would love any feedback and to chat with you outside and for the rest of the day. So thank you so much.